Today we're going to demonstrate the power of statistical process monitoring technology using the Rosemount 3051S pressure transmitter.
The 3051S is a highly accurate device that's used to measure pressure, DP level, and DP flow. In addition to pressure measurement, it also measures the amount of process variability or process noise. Statistical process monitoring, or SPM, calculates the process variability at a very high resolution, thus providing more insight into the process. In traditional practice, without the ability to calculate process variability at a high resolution, we would not notice some of the issues going on inside the process. For example, if an impulse line were to become plugged, the operator would not see a change in the pressure measurement. However, if we utilize the process variability seen by the 3051S and follow the 4 simple steps of the SPM model to collect, analyze, decide, and act, we can detect and prevent abnormal situations in the process. The first step is to collect as much information about the process as we can. We do this by trending the pressure and process variability inside a data historian. The second step is to analyze the information you have collected and to establish the baseline. As you can see here, the process variability calculated by SPM has decreased by over 50% from our baseline value. This is a direct result of me plugging the impulse line just a few moments ago. Now that we understand where the baseline value is and how much the process variability reacted to the abnormal situation, the third step is to decide on the threshold limits. We can set the threshold limits by accessing the device with AMS Device Manager. Let's configure for an alert based on a change of no more than 30% in the process variability. Now that we've configured the device, let's plug the line again.
The fourth step is to act on this information using our plant web alerts. As you can tell, the plant web alert has popped up on the alarm banner. The operator can then follow specific operating procedures to address this situation. The process engineers that need to investigate this further can use the Process History View application. As you can see, the plant web alert information is clearly labeled with the historical information of this device.
Remember, by following the 4 simple steps of the SPM model to collect, analyze, decide, and act, we can achieve greater understanding of the process and also identify future abnormal events.
Thank you for spending time with us. For additional information on how advanced diagnostics can help your facility's bottom line, please contact your local Emerson representative or feel free to visit the following websites.